we are going to be looking at section 4.2.1, and today we're going to be doing problems 58 and 59, and then when we meet in not in person, but when we meet together, we will be looking at the next few problems. Okay, so we will start with 58. And before you get started, on my website, I actually posted a link that says to print 4.2.1 resource page. You don't have to print it, but it will make your life easier. When you go to it, it'll look something like this image, and there will be 4 of them. Because we're going to kind of keep referring back to that graph throughout this section. So if you'd like to print them and just cut them out and glue them in your notebook, that's one option. Another option is just by sketching the graph yourself. So we will look at problem 58. We will do that one together, and then you guys will do 59 on your own. So for 58, it says, in the previous section, you learn how to use the graph of a system to solve an equation. We want to know, how can the graphs of y equals 2x squared plus 5x minus 3 and y equals x squared plus 4x plus 3, shown at the right, help you solve an inequality? So we're going to go through a few different steps to eventually solve an inequality. So it says, how are solutions of 2x squared plus 5x minus 3 equals x squared plus 4x plus 3 represented on this graph? So a big important thing that we should notice is this isn't actually solving a system of equations. If we were solving a system of equations, we would have y equals and y equals. This is just solving a problem, right? We're just solving for x. So one way we can do that is just by looking at their intersections. So I'm going to go ahead and put a dot where these lines intersect, and it wants us to describe how we got that. So the solutions, so they're not actually ordered pairs, but the solutions are the x coordinates of each point of intersection. So we are only going to list the x values. So obviously we could solve this algebraically, move everything to one side and factor and go from there. Another way we can do it is graph both equations and figure out their x values of intersection. So those numbers would be x equals -3 and x equals 2. Okay, moving to part B. So it says obtain a resource page. So you can click the link here or go to it on my website. On the resource page, we want to label each graph with its equation and highlight each function with a different color. How did you decide which graph matches which function? And then it just says, if you want to use the graphing tool, you are able to. So we need to first just color these in different colors, and then from there we need to kind of describe how do I know which one is which. So I'm doing that one in green, and then I will do this one in purple, and then from there we'll distinguish which one is which. So if you notice, one of the we'll do the green one first. We'll try and figure out what equation that should be. One of the equations has a 2x squared and the other one has an x squared. So one of them has an a value of 2 and the other one has an a value of 1. So it's kind of obvious that the green graph is actually stretched or moves at a quicker pace than the purple graph. The other thing that we can kind of tell is we can look at the c value or the y-intercept, and that will tell us where it crosses the y-axis. And so if we want to match 2x squared plus 5x minus 3 to a graph, we want to figure out, well, which graph crosses the y-axis at 0, -3, and that would be the green graph. So I'm going to just go ahead and write the equations in their colors so we have them. So y equals 2x squared plus 5x minus 3, and then the other equation, and I don't want to write in that big a font, would be y equals x squared plus 4x plus 3. We also need to describe how we decided this. So I'm just going to talk about 1. So I'm going to say the graph of 2x squared plus 5x minus 3 increases faster because of that too, and should intersect or cross the y-axis at 0, -3. Okay, so let's go ahead and move on to C. So for part C, it says, on the graph, identify the x values for which 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. Okay, so we're only talking about the x values. So basically, when does the green graph has smaller x values than the purple graph? So I'm going to just kind of highlight that. So the green graph is below the purple graph, all in this section. Now I'm only doing that just so we can kind of see it, okay? So how we are going to, let's first kind of describe it, because they do want us to describe how we are getting a solution. So we know that you look at when the green graph is below or less than the purple graph. Okay, now as far as, well, how do we decide those values? That's when those x values that we found at the beginning are going to come into play. So those are kind of like our boundary points. So those are always going to be important. So, well, I know it's something to do with -3 and 2, but if we're talking about when is the green graph below the purple graph, it's when it's between -3 and 2. So to show that, I can use an inequality. Now, why did I decide to use equal to? It's because when we look at this problem, the sign is an equal to. So we want to match that, okay? So let's go ahead and look at D. It says, how can these solutions be represented on a number line? Locate the number line labeled appropriately below the graph on your resource page and use a colored marker to highlight the solutions to the inequality on the number line. Okay, so we want to just plot this on a number line, so that should be fairly simple. So I'm going to just use a completely different color. So we want to show -3 as a solid dot and 2 as a solid dot, and we want to just highlight everything in between, showing that the solution is true between -3 and 2, including both of those numbers. All right, so for this, I'm going to actually just go ahead and label that D, because that will take care of that. And then looking at problem E, it says, what about the inequality 2x squared plus 5x minus 3 is greater than it? So now we want to know, when is it greater than x squared plus 4x plus 3? What are the solutions to this inequality? Represent your solutions algebraically on the number line. So now we want to know the opposite. When is the green graph above the purple graph? And it's when it's right here and right here. Now, we don't have to do shading. I'm just simply doing this so you guys can see it. So the shading is actually not part of this problem yet. Once we get to the end of the section, you'll see when we are going to shade. So for part E, my answer, I know that I will always express it using those x values of intersection. So it's when x is less than -3 or when x is greater than 2. And I know that because it's on the outsides. And the reason why I use a less than symbol or greater than symbol instead of the equal to is because that's what they used in the problem that they were talking about. So we would have a open circle at -3 and a open circle at 2. And then from there, we would want to go in opposite directions. Okay. So that should get you a good start on this section. So you guys will be working on 59. which just says consider the inequality. So it's actually looking at an absolute value inequality, which is technically something that we do in Algebra 1. So it'll first talk about how many boundary points are there. So those are technically like the solutions if you were to solve it with an equal sign. And then it's going to ask you how would you kind of show that on a graph. Okay, so I will let you guys get to it. So you will work on problem 59.